All right. Next, after the toggle and the button and text element, we can look at the sliders. Should be very familiar. So let's look at the sliders next, since we worked on them last week. So I'm going to create a slider. And it looks like it's a little bit longer than the ones over here. So we can reduce the width so it doesn't take up as much screen real estate. We can anchor it and move its position. And this one is going to change the size of what we're painting. So some things now we have to look at is, wait, what are we calling? Like, what property are we changing? And what are like the min, the max, and default values of that? So if I come up here, I created a float called size. It's a private float called size, and I just set it to 1/2 a unit. If you remember, when you create stuff, it has this default size, and it's 1. And I just thought maybe we can start off a little bit small. I just did 1/2 unit just with testing. So here's the line of code: primitive transform local scale equals new vector 3. It's a scale is a vector 3. And we pick a random number for x, y, and z. And it used to be just random range 0.1 to 1. So we don't want 0 because a scale of 0 would mean it's invisible. So the smallest number that made sense to me was 0.1. And 1 just means like the unit size, just 100%. And now we're just multiplying each one by size. So the user can move the slider and can update this size property, and then whenever we paint stuff, we just multiply by this size property. So so the logic is all set up, the property is set up, and then we just need a public method. We need something to listen to the event, something that can be called by it. So here we have public void change size, and it receives a float because it's a slider that we're messing with. And this temporary variable, we update our property to it. And the property is up here, and the property gets used in our logic here. All right, so that's all set up. But now we have to listen to it. So we have to say, okay, we're going to add a listener. It's on this game object. It's on this component object. And remember, we go up to the dynamic area. And here's change size. So if I click play, I paint. If I move the size, we notice that we're getting it's bigger and it's smaller. But there's a few things I forgot to do. So I forgot to set the min, max, and default. So for a size, anyway, 0.1. We can't go to 0. We max out at 1. And our default, as you saw with the property, setting the property was to 0.5. So here's our size slider. And we have it set up with our min, max, and default. But the user doesn't know what it's referring to. So the easiest way that I found to add these little like text labels so that they have a nice little background is to just make a button. And with the button, I'm going to go into underneath it, the text. I'm going to name it. So whatever that's supposed to be, size, and I'll lower the font size. Seems like 14 is what I'm working with. The button size itself, I can shrink it down to the size of the label. And I can position the button so it aligns with the slider nicely. And notice that they're like sister game objects. They're siblings. So I like to put that button underneath the slider just because it's part of it, but now I can move the whole thing together because it's inheriting the transform. And everything is underneath here, and I should really name it something. So slider size, so I know what it's doing, and I know all of its components, all of its game related stuff is underneath it. I think one thing I forgot to do was, okay, right. So I made this button, right? But it's not really supposed to function as a button. I just like it that it has an image component and that it's got a text component underneath it. But this button component I can get rid of. I don't actually want it to function as a button. It's not going to call anything. So you can either turn it off to disable it, or you could just remove the component, which I'm going to do. I'm going to remove that button component because it's not really functioning as a button. So now since I built this out, and I can reuse these so I don't have to build all from scratch. I can just duplicate it and call it red and just move it down. And we have another slider all set to go. And just gonna change the text element on it to red. And if you notice with the colors, first off we go from 0. Sorry, the colors are down here. So to set a color, we set vector 4, but we go from 0 to 1, right? And what we're really doing is we're changing that max amount of color that's allowed. So you notice here I have a property now, red, green, blue, and they're up here. So private floats, red, green, blue. Notice I declared them all on one line because they're all private floats. They're just separated by commas. So I don't have to use up 3 lines. Since they're all the similar nature, you can just define them all together. And they default to 0, but I don't want that. They actually start off or default at 1. So notice how I assign them all to 1, all in one line. Then I use those red, green, blues down here with whatever the user changes them to. It's really the max, the highest range. So they default to 1. So I go back to slider, and the min is actually 0 for color. It can be fully turned off. The max is 1, and we're going to default to 1. Awesome. And then the last part is we need to change it somehow. So that's what these 3 public methods are. They're the event listeners. This is what the event, when the event gets fired on the sliders, this is the public method that they can call. So they're all public, they're all void, they've got respective names, and they just receive a float from the slider whenever the user decides to interact with it. And it's just have some temporary name. And we're really just updating our properties, the red, green, blue floats, and they're used in our logic as I've explained. So for slider red, since we duplicated it, it's already kind of connected up, but it's calling change size, which I don't want to do that. So for red, it's change red. And for green, we duplicated it, renamed it, move it down. I gotta change the label on it. And we have to change the method that we're calling to change green. Then I could duplicate that, rename it. Move that down. Change the label on that. And change the event listener as well. And now we got 3 color sliders that should be functioning. So we paint full color. Let's pull down red. Now we have no red. Pull it halfway up. We have some muted tones of red mixed in. That looks good. We can pull out green. Yep, that's working. No blue. Now we just have muted tones of red. And I pull that all out and you just have black. Yep, works fine. Awesome. All right, next how do we switch the objects that we want to paint? So this is the last UI element, a dropdown. I'll call it dropdown, no, not destroy. Primitive, changes the primitive that we're going to paint. Anchor it to the bottom right. And I'm just going to slim it down, lower the width a little bit. And position it. All right, it's pretty good. So the dropdown has many game objects affiliated with it. I'm really just interested in this dropdown component right here. And here we have the options. What are we presenting to the user? So the dropdown maps to an enum. So much like the slider maps to a float and a toggle to a bool, dropdowns are really meant to be used with enumerations, are mappings, are lists of strings to integers. So you can present options to the user. For me, I will present a sphere, a cube, and a cylinder. And the only reason I'm offering those up is just that's the code I'm calling. So when you create 3D objects, I have this list to call from. So I just picked cube, sphere, and cylinder. All right. But we have a choice of 3. Okay, these are strings that are presented to the user, but notice on value change will send an integer. So these are mappings from strings to integers. This will be represented as a 0, as a 1, and as a 2. And you can add more or less, and it will just rebuild the enumeration for you. But remember, the enumeration is just a mapping of strings to integers. And so here's the strings we wish to show the user, and it'll be 0, 1, or 2. And then we have to say, all right, who are we going to call when the user changes this? What is the public event, the public method that will be the event listener? So here at the top, I've got my property. It's a private int called shape, and I'm defaulting it to 0. Although even if I didn't do that, integers default to 0 either way. And when there's user input, and we're going to create something, this is something that's new. We have a switch statement. So you've seen an if-else statement, and a switch statement is very similar. And sometimes you want to use if-else, sometimes you want to use a switch, just based on whatever you're evaluating. But they are both branching logic. There are statements that use decision points and execute different lines of code based on whatever the logical expression is you put into it. So here's the input, smooth brackets. Here's the block of code that gets executed, the curly brackets. And here we're passing in an integer. You can pass in anything and make cases for them, but we're passing in an int. And then we write out a case for each situation we're interested in. So since I'm controlling this situation, I'm creating the dropdown. The user can only pass a 0, a 1, or a 2, but it depends on your situation. But for me, I have, okay, I want to evaluate case 0, case 1, and case 2. And so this is just how a switch statements work. You call it a switch, and then you have to write out a case for each situation you want to check for. So if the user selects sphere on the dropdown and a 0 comes in, we're going to create a sphere. If the user selects the next option, which is a string that says cube, then we're going to create a cube. And if the user switches the switch statement to cylinder and they start painting, we're going to start creating a cylinder. So notice the cases have a semicolon. That's just the convention with switch statements. They've just been around for a long time, and the convention is that for each case, you designate the value that you're checking for, and you just use a semicolon, and then you have lines of code that you want to run. There can be many. I just have one. But then when you're done with the case, you have to say break. If you don't put a break in here, this will just, in case 0 gets evaluated, it's going to actually move down into evaluating other cases. So you need to say, okay, we're done. We run this line of code and we break. We break out of our switch statement. And if case 1 is run, we just run this and we break out. And if none of these cases are evaluated, then it just runs the default cases, like the basic catch-all. If none of these run through, just do this. Here, we're not doing anything, we're just breaking. If for whatever reason you had multiple cases that want to use the same logic, you just list out your cases in, one after the other, and they'll just, so case 0 and case 3 will generate a sphere. In this case, we'll never actually get to case 3 because the UI isn't set up to send that. Cool. So that's a switch statement, and that determines what we're painting, what we're generating. And now we need a public method for the UI event to call this method. And so an integer is coming in. It's a temporary variable. We just assign our property to it. And we use that property in our logic when we're painting. So over here, we set everything up. We just need to say, what are we calling? What method are we calling? So we're using our click position manager component object, and we're going to call that change shape, the dynamic. The only method that's showing under dynamics is the only one that receives an integer. Set paint, and I can switch to a cube and paint again, or switch it to a cylinder and paint. And that's why it's painting cylinders and cubes. But whatever you're painting, everything works. You can pull out red. You could delete stuff. You could turn off toggle time to destroy, and everything just works together. Awesome. And last but not least, we have this mouse position here. This is the only one that is kind of sending data in the opposite way. It's kind of, we're sending data to the UI. We're updating this X and Y. This is more to show you guys that indeed, when we check for mouse position, there is these X and Y values that change based on where the mouse position is. Down the bottom left is where we'll get a 0, 0 in this situation. So to create that, I just create a button. And let's see, mouse position. And I'll pin it to the bottom right, and I'll just move it. Then I have to start filling out the text. And so on the left-hand side, you see that, let's see, it's on 14 size. All right. So I'm basically filling it out with like sample text, like fluff text. I'm trying to figure out how big do I need to make my bounding box, my image behind it, with like what type of text do I think is going to be passed in at runtime. So I was just filling out, okay, there should be about this many number of characters. If you noticed, it was like, it could be from 0, it could be 2 digits or 3 digits. So like I was just trying to figure out what the biggest, so the biggest size is maybe it's like 999 or something. That this is like how much space I need. So notice it, like the bounding box needs to be a little bit bigger. So let me open up the width there and then change the position. And so, okay, this sounds about right. So I just was aligning everything, seeing how much text would come in. And now we need to send text to it. So basically I need to grab this Text Mesh Pro object. So to do that, Text Mesh Pro is like updated text for the UI, for Uni's UI. Just it so happens that it's using a different namespace. It's a little annoying, but anyway, public, and it's called like text mesh. They go pro UI GUI. So set a new mouse position. So now that I created this property, and we need to set it to something. Right now it's just null. So here, this new mouse position is now exposed, and it's really it's referencing the text of this new mouse position. So it's really referencing this. Now it's filled out fine. And then now that we have a reference to a text object, this thing, we need to go and we want to change this text property, which is a field. So to do that, it was at the bottom of my update loop. I just was calling. So basically what this was like new mouse position. Yeah. So it's saying this new text object that's now on the right side, go grab me its text property, and it says type string. So I need to set it to a string. So this is the hard-coded part. This never changes. And then here's a dynamic part. So what we're doing here is we're saying go get the input, the mouse position, which is a vector 3, but then go get me the x property, which is just the first float, and call the toString method on it. And if I take this out, just call toString what you're familiar with, it's just going to print out the float, but with a long decimal after it. But let's take a look at that. And then here's a hard-coded string, and then add the dynamic wherever the mouse Y position, the float is at that moment. But let's just see what it looks like with it. Just a generic toString print. And notice as I'm moving it, it's really the integer values that are more important. Notice that like the decimal numbers that are cut off, like they don't really change that much, and it's hard to read. So I kind of want to get rid of those decimal numbers. So to do that, you can send like a little command into the toString. This is like saying, give me 0 decimal places. So this cuts off the decimal places. So you could also like cast your float to an int and then do a toString. But this is like saying, oh, here's some formatting options I want you to cut that toString. No, so notice there's no decimal numbers now. It just represents ints. All right, so that was formatting into the toString. And that's everything you need for this week.